So hi everyone. Today we'll discuss about Java 8 features. The important features in our Java 8 features. So in Java 8 features, first of all, we have discussed about functional interface, and here we have to discuss about Lambda expressions. These all are the powerful topics nowadays. Every company is they're asking these concepts. Apart from the default methods, predicate, function. These are the predefined expressions. Double colon operator, double colon operator, Stream API. Nowadays, the trending topic is Stream API, Date and Time API. These are very important topics in our Java 8. Every developer must have the knowledge on all these topics. So, first of all, we need to start with functional interface. So, before starting functional interface, you must have the knowledge on interface. Interface is very important actually. So, what is an interface? Interface is a data type. Interface is a data type which consists of public abstract methods, which consists of public abstract methods. By default, interface methods are public and abstract. By default, interface methods are public and abstract. So, first of all, here you must have the knowledge on what is an abstract method. Abstract method is nothing but method without body is called as abstract method. General methods are basically divided into three types. Methods are classified. Methods are classified into three types. One is static method, other one is instance method, another one is abstract method. Static method, instance method, and abstract method. Static method means method with static keyword. Method with static keyword is static method. Method without any keyword. Method without any keyword is instance method. Method with abstract keyword. Method with abstract keyword is abstract method. Abstract method means method without body. Abstract method doesn't have body. Is it clear? Method without body is called as abstract method. So abstract method is unimplemented method. You can also call abstract method as unimplemented method. It doesn't have any implementation. Implementation logic you have to write in the child class. By default, interface methods are public and abstract in nature. So here interface is a data type which consists of public abstract methods. By default, interface methods are public and abstract. And here interface methods must implement. Interface methods must implement in child class. And by using interface, we can achieve multiple inheritance. By using interface, we can achieve multiple inheritance. When interviewer will ask you about interface, you tell all these points. Interface is a data type which consists of public abstract methods. By default, interface methods are public and abstract in nature. Is it clear? So, by using interface, you can achieve multiple inheritance. Here you can ask one question. What is multiple inheritance? Simply, I can tell creating a child class by using multiple interfaces. Creating a child class by using multiple interfaces. That is multiple inheritance. Java does not support multiple inheritance. Does not support multiple inheritance by using classes. Multiple inheritance by using classes. So we can achieve multiple inheritance by using interfaces. Because before going to functional interface, you must have the knowledge on this regular interface. Java does not support multiple inheritance by using classes. We can achieve multiple inheritance by using interfaces. Is it clear? So let us see one example here so that you'll understand. Let us assume here I have one class. I have one class with name A, and here I have one method, something like I'll write public void show. This is one method. And here if I write one more, no need to write any method also. Just there is one class with name A. Here I have one more class with name B. Here also bracket close. Here I'll create one more class C extends A comma B. So the syntax is not supported in Java. Coming to interface. Interface A. Creating a child class by using multiple interfaces, that is multiple inheritance. Interface B. Here also bracket open and bracket close. Here I will create one class C implements A comma B. This is also this syntax is supported in Java. So Java does not support multiple inheritance by using classes. This syntax is not valid, and we can achieve multiple inheritance by using what? Interfaces. So when interviewer will ask you about interface, you have to speak a lot of points related to interface. Is it clear? So these are the points you must know. And one more point I will tell something like by using interface. And one more important point is we cannot create object. We cannot create object for interface. We cannot create object for interface, but we can create reference. But we can create reference. Is it clear? With interface reference. And here one more important point is interface methods must implement. Interface methods must implement in child class. So let us see here. For example, if I try to create one interface here, interface, and the name I'll give as A. Here I'll write one method. By default, interface methods are public and abstract. By default, interface methods are public and abstract. Is it clear? So interface methods must implement in child class. Interface methods must implement in child class. Here I'll write one method, void show. So this is an abstract method. You don't need to again write public and abstract. And here I'll write one class B implements A comma B. Sorry, implements A. Now here the interface concept abstract method. Abstract method means method doesn't have body. Body you have to write in the child class. So here again you have to write the same method, public void show. So simply you can tell interface methods must implement and override in child class. Here I'll write system dot out dot println of. I'll try to print I am show, something like this. So here you must have one regular class. Always write the main method in separate class. So I'll get one class with name test. And here in this class, I'll try to write one main method, public static void main. String args is also there. I'm not writing here. And here I'll try to create an object for interface. A1 is equal to new A of. So if I try to call the method A1 dot show, here you will get error because we cannot create object for interface, but we can create what? Reference. We cannot create object for interface, but we can create what? Reference. So here, this line you will get error because we cannot create object for interface, but we can create what? Reference. For example, here you have to write something like this. A1 is equal to new B of. This is valid actually. So whenever here, what is the meaning is object is created for B class, reference is created for interface. Interface and implemented class. Interface will provide some set of powerful definition you can tell in interface. Interface is a contract or an agreement. Interface is a contract or an agreement between itself and its implemented class. And its implemented class. That is, whenever we declare an interface, whenever we declare an interface, it means that we are providing some set of specifications, and that specifications must implement in child class. Interface is a contract. Interface is a contract or an agreement between itself and its implemented class. So whenever we declare an interface, it means that we are providing some set of specifications, and that specifications must implement in the child class. Did you understood? So actually, when you work with solid principles, so generally you already know OOPS. In OOPS, you have some principles are there like abstraction, encapsulation, inheritance, and polymorphism. And in OOPS, you know some concepts like class, methods, constructors, and all interface and all the other stuff. So solid principle is nothing but applying the OOPS principles efficiently at the time of application development. SRP principle, single responsibility principle, OCP principle, open closed principle, LSP principle, LISCO substitution principle, ISP principle, interface aggregative principle, DIP principle, dependency inversion principle. These all are comes under solid principles. So what this LSP principle? If you want to know more about solid principles, you can watch my videos in YouTube. Solid principles by Kannababu. If you search, you can watch that video. Or solid Kannababu also will get. Okay. So this is LISCO substitution principle. LISCO substitution principle. So what this principle is telling, LISCO is a scientist actually. He told this principle. Superclass types must replace with subclass types. Superclass types must replace with subclass types. Type means here some generally whenever you create an object for a class. For example, I have one class A, bracket open, bracket close. Here I have one more class B, extends A comma B. One class A, one class B. Extends A, sorry. So here you see, here what this Lisco is a scientist actually, what he's telling. Generally, if you create an object for class A1 is equal to new A of. What is telling means superclass types. Superclass object can replace with subclass object. Did you understand? Your object for A we created now. What is telling? You keep the reference as it is. Superclass type can replace with subclass types. In our language, you can call this one as upcasting. Both are same actually. Upcasting means subclass object assigned to superclass reference. Superclass reference. That concept is called as upcasting. So similarly, when you work with interface also, here you have interface A. And here interface consists of abstract method that we already know. And interface methods must implement in child class. So here you write class B implements A, not extends. Previously also here I think I written extends, I think. This is implements actually. Implements on the right, good. So in this scenario, what you have to do? That's why we will never create object for interface. If interface is there, 100% implemented class will be there. So here you can apply this LSP principle. Whenever interface is there, you have to create object for child class, reference for interface. And with interface reference, we can access the implemented methods. For example, here you can ask void show. There is one method show, and it will try to implement that method here, something like this. Here I'll try to implement the method. Here I'll write public void show. Here I'll try to implement that particular method, something like this. Is it clear? Here I'll write system dot out dot println of I am sure. So what methods we can invoke by using interface reference means implemented methods. Generally, if I call a1 dot show, the output will be I am sure. Did you understood? So I am covering a lot of points related to interface. One is multiple inheritance. Another one is we cannot get object for interface. Another one is whenever interface is there, 100% implemented class must exist. We will never create object for interface, but we'll create the reference for interface. Different scenarios where we'll use this interface. Are you following? And another scenario I'll try to explain. In solid principle only you have one more beautiful principle called ISP principle. Which principle? ISP principle means interface segregative principle. Interface segregative principle. What this principle is telling? Don't force, don't force the class to implement. Don't force the class to implement interface methods. For example, if I create one interface, I'll give the name for the interface is A. And in this interface, I'll create one method, something like void show. Is it clear? Here I'll create one more method called void display. There are two methods are there. And here I'll try to create a class B implements A. So whenever you create an interface, it means that we are providing some set of specifications, and that specifications you have to implement in child class. Here you have one method show. So the show is abstract method. But class B, it is mandatory for class B to implement both the methods. Public void show, bracket open, bracket close. For example, if this class B implements only the show and not implementing display, it will raise an error. It means that we are forcing the class to implement the interface methods. But what this ISP principle is telling, don't force the class to implement the interface methods. In interface, you have two methods. You're implementing only one method. So error will come. It is mandated to implement this display method also. So what this ISP principle is telling, one interface consists of only one method. Don't write multiple methods in a single interface. One interface consists of only one method. So your interface is A. Here you can get one more interface with name what? B. So if you want to create another method, you create another interface. Void display. And these all are abstract methods only. These all are abstract methods. So we're not forcing the interface to implement these methods. Class B is implementing only show because it wants only show. But there is one more class called C. This class C wants to implement both show and display. So here what you can do, here you can give A comma B. Here you can apply this multiple inheritance. We are not forcing, depending on the situation, which class wants to implement which methods, we are giving the priority for them to implement. So public void show, this is one method. And here we have to implement the display method also. Here you can write public void display. So we are not forcing. Class B don't wants to use. Sorry, here I think I'll give IA and IB so that you will not confuse. Here IA because always interface name starts with I, IB. Okay, this is B class. So class C want to implement both show and display. Is it clear? So you can apply multiple inheritance here. So from this solid principle, ISP principle, Java 8 has introduced a new concept called functional interface. They introduced a new concept called what? Functional interface. So functional interface is also called a single abstract method interface. Some points. Functional interface must declare with at the rate functional interface annotation. At the rate functional interface annotation. Whenever you want to declare functional interface, you have declared this one at the rate functional interface annotation. Annotations are very, very important when you work with Spring Boot microservices. You try to understand what is the use of the annotations. It is functional interface is also called functional interface is also called as single abstract method interface. Single abstract method interface. So this interface is following the ISP principle. That interface consists of only one abstract method, not more than that. In olden days, we already know. It understood. Interface consists of only abstract methods. You cannot write static methods or default instance methods in interface. But in Java 8, they introduced, they have given permission that you can declare the static methods and default methods also in functional interface. So we can write default methods. Why? We can write that we'll discuss later. We can write default methods and static methods. Static methods in functional interface. Functional interface. And one more point I will tell. Later I will explain. Give me some time, but just I will explain that point. The implementation of functional interface. The implementation of functional interface. Or you can simply tell, we can implement the functional interface. We can implement, see, anywhere you talk about interface means implemented class is mandatory. We can implement the functional interface by using lambda expression. By using the lambda expression. So simply you can tell lambda expression is the implementation of functional interface. Most frequently Predefined functional interfaces in our Java. Predefined functional interfaces in Java. In Java, you have a lot of predefined functional interfaces are provided. One is runnable. It is a predefined functional interface. Other one is callable. It is also a predefined functional interface. Another one is comparator. It is also a predefined functional interface. Another one is consumer. It is also a predefined functional interface. Another one is predicate. It is also a predefined functional interface. Other one is function. So a lot of predefined functional interfaces are provided in Java. Java 8. So in Java 8, the first important feature is functional interface. Functional interface must declare it at the rate functional interface annotation. It is also called as single abstract method interface. You cannot write more than one method. For example, let us show an example. Here I'll create one interface. The name of the interface is my interface. Bracket open, bracket close. So generally when you create an interface, you have a permission to write how many methods you want. Void show, void display like that. But here I want to create this interface as a functional interface. So you can declare this interface as at the rate functional interface annotation. Then you don't have the permission to declare more than one abstract methods in this interface. If you write void display, you will get error here because no permission. It is a functional interface. It requires only one abstract method. And it will allow default methods also. Default method must declare with the default keyword void. Here you can write default void, and here you can write some my method, my def method, default method. The default method will have body. Generally, interface consists of only abstract method now, but in Java 8 they introduced a special method called default method. Here you can write what body system dot out dot println of I am default method, something like this. And apart from this, from Java 8, they introduced static methods also. If you want to write any static method, you can write inside the functional interface, my static method. But these features are not available in old interface, what we discussed earlier. So here I will try to print system dot out dot println of I want to print I am static method. Are you following? So this is about functional interface. Is it clear? Interface concept abstract method. Single abstract method interface is functional interface. Are you following? So the point is, generally in olden days, what happened, how we write the program actually in olden days. Generally, for example, in olden days, in your regular core Java, we will create an interface. The name I will give as IA, some interface name I will give. Bracket open, bracket close. Here I'll write one method, public, abstract method now. Here I'll write void print. One method I will write here. And here I'll create one implemented class. Class B implements A. Class B implements what? A. So interface consists of abstract method. That abstract method logic you are writing in the child class. So generally here you will write public void. Here I'll try to print. I want to print one message. I am implemented method. I am implemented method. Something like this I will print here. Are you following? I am implemented method. Now I'll create one more class with name test. Here I'll try to write something like public static void main. Public static void main. Now I'll try to create an object for my class. This is the regular style of programming, old programming. IA A1 is equal to new B of something like this. And I'll try to call the method A1 dot print. So the output is I am implemented method. This is your regular code actually. So actually what is happening here, you're creating a class and you're creating an object. Why you're creating the object for the class? Your target is to execute this logic. Listen carefully. Your main requirement is to execute this logic. That is why you're calling the method. In order to call the method, you're creating the object. So your main target is to execute the logic. You're calling this method here, print method. Whenever you call this print method, this public void print of, I think it was, sorry. I'll try to write like this. This is one method. Here I'll write system dot out dot println of I am implemented method. Good. So now let us see. Interface consists of print method. Interface method was implemented in the child class. Okay, implemented. Very good. Now here I'm creating the object and here I'm creating the reference. I'm calling the method. When I call the method, this logic will execute. But now current trend when you work with collections or data JPA, very heavy code you have tried. You have tried queries on collections basically. In that scenario, what you have to do, So why do you call this method? Is it clear? Why do creating an object? So what is telling developer, you don't write this code. Don't call this print method. Don't create an object. Don't write this public. Don't write this void. Don't write this method again. Okay, na? And don't write this bracket. Don't write this what? Class. Your target is to execute the logic. Very good. So directly assign this logic to this interface reference. Assign the logic to interface reference. This logic is lambda expression. So the include. So what this Java 8 is telling developer, you don't write the class because you written the interface very good and decorate this interface as functional interface. I'll understand it is an interface. And here developer, you don't create what object. Don't call the method. Directly assume the logic here. So what to do? Parameters, input parameters greater than or equal to, here you can write system dot out dot println. This is called lambda expression. Here you can print one message, code executing or method called or implemented, I am implemented method or logic executes, something like this. Are you following? And you will try to call this method because the method name is there, na print. Simply you can call this method a1 dot print off. So this is called as lambda expression. So see how the code is very simplified nowadays. In olden days, we used to write interface, implemented a class, interface method logic you implement in the child class, and then you create an object, send the object to the reference, and again call the method. So the implementation of functional interface is lambda expression. So this is called as lambda expression. What is lambda expression? Lambda means input is equal to greater than output. Generally, how will write the method actually? You'll write a method. For example, I'll write one method void add of int x, comma, int y. And here I'm trying to print one message system dot out dot println of x plus y. Generally, you write the method like this. But now what it is telling developer, you don't write public, you don't write void, you don't write int, you don't write int, you don't write bracket. Simply what you can write IA, A1 is equal to input. You pass two inputs x comma y. You are sending two variables as input is equal to greater than system dot out dot println of here x plus y, something like this. And here you can call the method a1 dot add of 5 comma 3. So let us assume that here in this interface you have one interface you can create otherwise. Here let us assume I create one interface IA. Already that is there. You see this separate example. Here I'll write one method void add of int x, comma int y. So this is an abstract method. So the implementation of this method is lambda expression. So this point you have to elevate when you practically speak about this. There is a relation between functional interface and lambda expression. Did you understand? So the implementation of functional interface is lambda expression. Simply you can tell that one. This is your interface. This is your lambda expression. This style of programming you will see frequently when you work with data JPA, when you work with Spring Boot or microservices, frequently when you work with collections or other stuff, it will be helpful. Did you understood? For more videos to like, share and subscribe this channel. Thank you. Catch you later in the next video.